So when building a campfire, you need three things. You need wood for the fuel, oxygen from the air, and some external energy source, like a spark. Well, explosives are actually more similar to a campfire than you might think. That is, explosives have both the fuel and the oxygen that they need for combustion on one molecule. And whenever we shock an explosive like this, we can impart a huge amount of energy, and by doing that, we can eventually lead to this process that's referred to as a detonation. A detonation is the rapid release of heat and gases, and all of this happens faster than the speed of sound. It's critical that we study explosives and the detonation process, not only for national security, but for global security. Explosives like the ones that I work with are found in nuclear weapons, and we need to know how they're going to act without actually setting them off. We also need to be able to develop better, safer explosives, explosives that are less sensitive so they don't accidentally detonate. These are just a few of the reasons why detonations are at the center of my research. In my research, I look at the first few nanoseconds after a shockwave arrives at an explosive in order to learn about the chemistry of explosives and the mechanisms that lead up to detonation. And I'm able to do this by using my group's novel shock compression system. Our system uses a microscope, but what's so special about this microscope is that we can shoot hundreds of tiny little explosive samples in a day. And again, this is possible through our tabletop microscope. We can take one of our high-powered lasers and focus it onto an aluminum foil and essentially eject a little aluminum bullet. That bullet can then go and shock the tiny explosive charges that I make, imparting that energy and initiating that chemistry. With these types of experiments, we can learn things about the pressures and the temperatures that are reached in an explosion. And again, these data are valuable for national security and global security. But what I find the most compelling about my research as a chemist is that really opening up uncharted territory when it comes to the questions we can ask. Questions like, how do cells and proteins act whenever they're shocked? How can we use our shock compression system to develop better bulletproof armor? And all of this is now possible through both our novel experimental techniques and through studying the chemistry of explosives. Thank you.